Okay, this is part 3, unit 6C, and we're looking at the normal distribution. And so now we're going to talk about looking at the standard scores that we discussed previously and the idea of a percentile. And so once we know the standard score of a data value, the properties of the normal distribution allow us to find the data value's percentile in the distribution. You've probably heard of the idea of percentiles, and so we're going to clarify what they mean here and then how we can find them. So for example, if you hear someone, say you scored in the 45th percentile on the ACT, what that means is that, SAT, 45% of the SAT scores were equal or lower than you. And so that's what we mean by percentile. And so if you're looking on our bell curve, the higher you are up, so say you're up here on the bell curve, the higher the percentile. So say this is a 97% of the data is below that point. That would be the 97th percentile, because that means that 97% of the data is either at that point or below it. And so that's how we describe a percentile. The higher the percentile, the more scores there are below you or that are less than or equal to you. So again, there's that information about percentile. So then what we can do is we can convert these standard scores to percentiles with computer software or a standard score table. And we're going to be looking at this table 6.4 right down below here in just a moment. And that's going to help us find a lot of the standard scores in the normal distribution and their associated percentile with that. And so when we look at this, if we take an example here, if we look at, it's giving us 0.15. So if we come and we find 0.15, so if you have a z-score of 0.15, meaning your standard score is 0.15 standard deviations above the mean, then that is the 55.96, approximately 56th percentile. And so again, the higher the z-score, the further you are above the mean, the bigger the percentile. So you can see, another example here, if you're one standard deviation above, that's the 84.13 percentile, which is very close to what we had in our previous example, which is 84%. But if you're below the mean, then say your z-score is negative 0.3 as an example, then you'd be the 38.21 percentile. Then you can flip that around, and you can say, well, suppose that I am the 75th percentile. Where would I range as far as being above or below the mean? What would be my standard z-score? So you can see 75 is going to be somewhere between these two numbers right here. So if I look at that percentile, so that means your standard score is going to be somewhere between 0.65 and 0.7. Again, the table is limited, so software will be able to get us more accurate results. But in this, we're just going for general basic stuff. If you continue to Math 1040, we'll get more accurate in statistics. So that's kind of how you can tell. So if you were on 75%, it's about halfway between there and about 0.67-ish. So now let's take a look at a few examples and how we would use this. So we're going to be using that table, so I'll be scrolling back up to it, to find the standard score and percentile of the following data values. So if you have a data value that is one standard deviation below the mean, what is the standard score? Well, if you're one standard deviation below the mean, then that's just a z-score of -1. And the percentile, so I'm going to go find z equal to -1, which is right here, and that associated percentile is going to be 15.87. So it would be the 15.87 percentile. Okay, and B, if you're 0.5 standard deviations below, that would be negative 0.5, because again, you're below. So then you go up, you find negative 0.5, and right there is the 30.85 percentile. 30.85 percentile. And then lastly, 1.5 standard deviations above the mean. So you can see 1.5 standard deviations above the mean is 93.32 percentile. So that's going to be a z-score of 1.5 positive, because you're above the mean, 93.32 percentile. Okay, so once you've got that standard score, and whether you're above or below, you can instantly find the percentile. Now we're going to flip that around. So we want to find the approximate standard score. So we're not going to have to get down to the nitty-gritty that technology does. We have to use a table. And then we're going to say the approximate number of standard deviations that the value lies above or below the mean. So if we are looking at the 30th percentile, what's going to be the standard z-score that goes with that? Okay, we got to come up here and we've got to find the 30th percentile first. So 30 is going to be somewhere between negative 0.5 and negative 0.55. And, so we'll call it about negative 0.52-ish. So the z-score is going to be approximately negative 0.52. It's going to be somewhere in the middle of those. And so you are 0.52 standard deviations below the mean, since you're negative on that. Okay, the 70th percentile. So I'm going to come up here, and it's actually kind of just on the flip side here. So we're between 0.55, 0.50, and we're going to be about halfway between. And if you look at symmetry, then it should be about the same as we did before, because 30th percentile is 20% below the mean. 70th is 20% above the mean. Since it's symmetric, we're going to get 0.52, and this will be 0.52 standard deviations above the mean when you go to the 70th percentile. Okay, lastly, 55th percentile. So we're going to jump up here. We're going to find out 55. Okay, this one, 55 is going to be somewhere between 0.15, 0.10, and so we'll just call it approximately 0.12. And so and it's going to be positive because we are 0.12 standard deviations above the mean. So that's how we'll look at percentiles and standard z-scores and trying to determine the correlation between the two. And if you know one, how to find the other, and vice versa. So that wraps it up for Unit 6C. If you do have any questions, please do not hesitate to let me know, and I appreciate your time.